What are we doing today? Triangle areas. We talked about this a little bit on Tuesday, didn't we? All right, let's focus on this today. All right, let's say I gave you a side case. Excuse me, gentlemen. Talking in the dean's office. Not here. Unless you raise your hand. All right, so let's say I gave you side example. Whoopsie, what's that? I don't like it. Okay, try this again. With this. Okay, there you go. Let's say A is 3, B is 4, and C is 5. On the triangle ABC, how do you find the area? Half the perimeter? Yeah, you could do that. That's that Heron's formula, but you don't need to. Why not? That's Heron's formula, right? You don't need that yet here. That's too much work. There's an easier way. Isn't this just base times height over 2? Because the base is, that's any leg. Who's a leg? 3 and 4. Why do you know that they're legs? In other words, is it a right triangle? How do you know? Because 3 squared plus 4 squared is 5 squared, right? You know? All right, so if it's a right triangle, it's easy. And why don't we just draw it just for fun? Let's say this is A is 3. Whoops. I'm sorry, what? Quiz you tomorrow, yep. Check Edmodo, everything's there. B is 4. Really? I kid you not. Why is this not looking good? B is 4. It keeps on doing this. What is this doing? I don't want that. All right. So B is 4. And C is 5. Or if you like, this is big C, this is big B, and this is big A. So it's a right triangle because it satisfies the Pythagorean theorem. And so clearly all you have to do is make one leg the base and one leg the height because there's your right angle for the altitude, right? Okay, so the area is 1/2 base times height. So 1/2 what? 4 could be a base. I drew it as 3, but okay. Times 3 is 6. Now, what if this was in feet? What do you have for your answer? 6 watts, not feet. Because you did feet times feet, didn't you? So feet squared, right? Typically, area is in units squared, volume is units cubed, that kind of thing, right? All right, so that's the easy case. That's just 1/2 base times height. Very easy. If you know the base and you know the height, you're done. All right, what if I gave you, let's say, a side angle side case? Everyone okay with this? This is just an example, okay? All right, let's try another one. Side angle side. So if you have side, and it's a right triangle, it's easy. What if it's side angle side? Let's say I gave you A and B are 8 and 6 inches, let's say. But big angle C is 30 degrees. So you don't know if it's a right triangle or not. So you can't do what we just did. So what do you do? Well, let's see. Let's look at what it looks like if you grab it. Let's draw it. But it may not be 6, 8, 10 because you don't know if there's a right angle. Right? How do you know? You'd have to solve the whole triangle to see if there's a right angle first. That's a lot of work. So let's see. If this is angle C is 30 degrees, and this is side A is 8 inches, and this side B is 6 inches, so there's big B. How do you get the area of the triangle? But why? He's saying 1/2 AB sine C, but why? Say you don't remember that formula. Where did we get that from? How did we get that? We don't have all sides. Can't do that thing. We're going to get to that in a minute. But let's say we pick one side. Let's say side A is the base. One side that you know, make it the base. How do you get the height? The altitude, right? We don't know where the right angle is, right? So let me draw that a little different here. Let's say it's there. How do you get H? The base is 8, but what's H? How do you get H? Well, we drew a right triangle, didn't we? So you can use, well, not Pythagoras because we don't have all the 2 sides to get the third side. So, which one? Is it sine? Yeah, the sine of 30 degrees is what over what? Opposite over hypotenuse. So here's the angle 30, opposite over hypotenuse. H over 6. So how do you get H alone? Just multiply, right? So H is 6 times the sine of 30. All right, so the base is 8, and the height is 6 sine of 30. All right, let's write that. The area is 1/2 the base times the height. Okay, and you can plug that into your calculator if you want, but don't you know the sine of 30? It's 1/2. All right, so I've got half of 8 is, and half of 6 is, so the area is 12 what? Inches squared. Okay, square inches, right. All right, so what did we really do? Didn't we do, look at this, 8 is the A, 6 is the B, and 30 is the big C. That's another area formula for a triangle if you have a side angle side. If you have two sides, say A and B, and the included angle that those two sides make, angle C. Now it doesn't have to be, what if you didn't have A, B, and big C? What if you had little a, little c, and big B? What if you had little c, I don't know what it is, little a, and big B? Say you had those three pieces. Could you still do this? It would be 1/2 AC sine B, right? Likewise, what if you had little b, little c, and big A? 1/2 BC sine A. So you permute sort of like the law of cosines. You can do it for any angle, any one of the three. As long as you got sine angle side, you're in business. It's just, this here is big C. Sine of the angle, right? The big letters, those are the angles, right? Okay, so 12 square inches. Fine. So if it's a right triangle, easy. 1/2 base on side. The base is one of the legs. The height is the other leg. If you have side angle side, 1/2 AB sine C. We proved that using SOHCAHTOA, right? You could just do SOHCAHTOA like we did, or you could just remember this formula. All right, but what if I gave you a side, 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 and it's not a right triangle? That's the thing you guys were talking about before, the heron, right? All right, here we go. How about if I gave you side, side, side? You can always do heron with side, 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 even if it's a right triangle. But what if it's not a right triangle? Then you can't do it the easy way. You got to do it this newfangled way, right? So what if it's side, side, side? Let's say A is 4, B is 5, and C is 7. I don't know, feet. So don't forget tomorrow's party. We're having a big celebration tomorrow. It's called a quizzy. Don't forget your quizzy. What's on the quizzy? Everything on the last quizzy plus what we did this week. What was on the last quizzy? SOHCAHTOA and law of sines. Well, what did we do this week? Law of cosines and area. No, it was one whole page. 5 questions, actually. All right, and so let's draw this thing. Now, I'm not going to necessarily draw it to scale, but let's say this. I guess 4 is the shortest side. Let's put it here, just for fun. And I don't know, which one's the longest side? Where, though? Which one looks longer? Down here? All right, so say that's 7 feet, 4 feet, 5 feet. Why is it messing me up? Okay. Alrighty, so this is big A, the big B, big C, like that. Okay. Now, so do you remember how Heron's formula works? By the way, this is not Pythagorean, is it? Right? Is this, in other words, a right triangle? No, because 4 squared is 16. 5 squared is 25. What's 16 plus 25? It's supposed to be C squared if it's Pythagorean, right? So A squared is 16, B squared is 25. 16 plus 25 is 41. Is that 7 squared? No. So it's not a right triangle, so you can't do what we did in the first example. So you remember how Heron's formula goes? First you got to figure out S. What was S? Half of the perimeter. How to get perimeter? Add up all the sides and divide by 2. So A plus B plus C divided by 2. Semi-perimeter. perimeter, half a perimeter. So what is that? Is it 19? What is it? 16 divided by 2 is 8. Okay, so the semi-perimeter is 8 feet. All right, now what? How does the formula go, do you remember? The area is S times S minus A times S minus B times S minus C, but you got to square root it because otherwise it's feet times feet times feet times feet is feet to the fourth, right? That's area, feet to the fourth. Are we in the fourth dimension? I don't know about that. But if you square root feet to the fourth, you get feet squared. Oh, I like that. That's good. Okay, so let's do it. A equals the square root of, okay, what should I plug in? 8. 8 minus 4, 8 minus 5, and 8 minus 7. By the way, this is also a test for the triangle inequality. What does that mean? You don't have a triangle. These three sides don't make a triangle unless any two sides add up to more than the third. Right? Is 4 plus 7 more than 5? No. 4 plus 7 is 11. It's more than 5. Is 4 plus 5 more than 7? Yeah. Is 5 plus 7 more than 4? If you said no to any one of those questions, you couldn't draw a triangle out of these lengths. Why do I say this is also a demonstration of that? What if it was 8 minus 9? Square root of negative. Bad. Right? So this will fail if it's not a triangle. Okay, so what is it? What is 8 minus 4? So you got 8 times 4 times, what's this one? 3 times 1. All right, the square root of 1 is easy. Now you can multiply it all together. 3 times 4 is 12 times 8? 96. But don't you have to reduce it? Right? Rad 96 is the answer, but we can reduce it. What is rad 4? 2. So rad 1 is 1, rad 4 is 2, rad 3 is going to stay in the radical, right? What about rad 8? Do you know how to simplify rad 8? Are there any perfect squares that go into 8? 4, so 4 times 2. So instead of rad 8, it's rad 4 times rad 2. What's rad 4? 2. So this is really the same as 2 rad 2 times 2 times rad 3 times 1. How do you write that simply? 2 rad 2 times 2. What's 2 rad 2 times 2? 4 rad 2. What's 4 rad 2 times rad 3? 4 rad. I'm saying 2 rad 2 times 2 is 4 rad 2 times rad 3 is 4 rad 6. Right. You can multiply the outsides 2 times 2. You can multiply the insides rad 2 times rad 2. So 4 rad 6 is your final answer. Yeah.
How do you know when to use the law of cosines and the law of sines?
You have to decide. I would say if it's a side angle side or a side side side, you use law of cosines. Start.
You can choose whatever you want to.
If it works.
Okay.
Yeah.
You can't use the decimal form.
Well, I remember if you can give me an exact answer, I want it and the decimal. If there's no way to get the exact answer, you're just tracing something off a curve on the calculator, you're getting decimals only, that's an answer. Okay? And don't forget units. 4 rad 6 what's? Well, he was saying how do you solve a triangle? The theme of this week so far before areas was if you have side, 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 or side angle side, it's easier to start with law of cosines if you're solving a triangle. All right, otherwise start with law of sines. That's fine. Now, don't forget units. What did we say they are? Feet squared, square feet. Okay, so might as well write that somewhere. And again, if you got an exact answer, you could also give me a decimal answer, right? Let's get a decimal out of this. Let's see, what's not that? Wake up. All right, so clear this. Let's make this big. All right, so we had rad 96, but we said that's the same thing as 4 rad 6, right? Wait, 4 rad 6, is it?
Yeah.
Yeah. So what do you write for your decimal approximation on your paper? 9 point. 9 points. Is it 800?
800.
Wait, no. Why are you saying 8? 9798. Aren't you rounding up?
Yeah.
Right, this is 5 or more over here, so round this one up to 8. So 9.798. So we're going to say it's about 9.798 square feet. There you go. Now, I reduced here, but you didn't have to. Could you have reduced here? Do you know anything that goes into 96? It's a perfect square? Question.
16. But when you're saying like feet squared, like are you saying that you're supposed to square your answer or like?
No, that the units are square feet. The units are square. Like, think about it. What if I had the base and the height, right? Let's say the base was 7 and the height was 8. Then you'd have 7 feet times 8 feet is so many square feet, right? That's just units for area. The number stays the way it is. Leave it.
Okay.
Yeah.
Do we have to do the radical or can we just make the inch of the decimal?
Well, again, if you can give me an exact answer, I want to see it. Right? And if you have an exact answer, then I get 2 for the price of 1. I get the decimal too. All right, questions, comments, problems? Anybody? Anything? Good? We're good? And I rounded off to 3 places. Yeah, if it's wacky, irrational number, right, you don't need to write them all down. Just give me 3 places. Okay? What else was I going to say? Oh, could you have reduced it this way, though? What if I said rad 96? How do you reduce that? Is there a perfect square that goes into 96? 16 goes in, right? Hint, hint, hint. Rad 16 is 4, right? It says, is 16 times 6 96? So rad 96 is the same thing as rad 16, rad 6, and rad 16 is 4, so 4 rad 6, right? Or you could have done it in pieces. What if you took out a 4? How many times does 4 go into 96? Can I what? Calculator y equals? What do you mean? 96 divided by
X squared.
Yeah, what is that going to do?
And then do a second graph and look for square.
Oh, you can look for the perfect squares. Yeah, you could do that. Yeah, I like that. And then you get like a hyperbola, weird shape, like it goes.
No, just give me 4 graphs.
Well, I mean, you could just do this arithmetically. Yeah, you could do that. But look, is it easy to divide by 2? Chop 96 in half. 48. Now do it again. 24. That's divided by 4. Right? So you can take out rad 4. Rad 24 is 2 rad 24. But doesn't rad 24 still have a perfect square in it? What? 4. So 4 into 24 goes 6, right? So you got 2, rad 4, rad 6. What's rad 4? 2. So you got 2 times rad 6, same thing. Right? You can break it down, one piece at a time. Whatever perfect square you see. If it's smaller than that, that's fine. All right, let's take a look at some samples from the homework. And so, what was our homework tonight? Homework is 441 multiples of 5. So I'm on page 541. Actually, 541. Take a look at number 1. Let's try number 1. Just for practice. No, we're just working together on this. All right, so page 541, number 1, says, what if, well, they gave you the diagram. I'm going to write it out. What if, let's see, they give you little a and little c and big B. Okay, let's say little a is 2, little b is 4. No, sorry, little c is 4. They didn't label this correctly, so it's messing me up. And big B is 45 degrees. All right, so how are you going to find the area of this triangle? That's the question. Find the area. And again, let's say there's units, inches. Well, first you want to see what it looks like, right? Why not draw it? I like to draw it, so let's draw it. And let's say, I don't like it. There you go. All right, so let's say, I don't know, little a is here, 2 inches, and let's do this, A, B, C, right? So little c is here, 4 inches, and big B is here, 45 degrees. So how are you going to do this one? Is this a right triangle, 1/2 base times height? Or you already know the height if it's not a right triangle? Is this side angle side or side side side? Side angle side. So do you need Heron's formula, what we just did a minute ago with that A plus B plus C over 2? No, this is 1/2 AB sine C, except you don't have A, B, and C, do you? So 1/2 AC sine B. All right, okay. So the area is 1/2 AC, A. You got a weird looking A there. AC sine B. All right, you finish it. Go. Remember, exact answers are preferred, decimal answers are required. Okay, did you get an answer? Okay. Okay, and you get an exact answer. Don't we know the sign of you gotta remember stuff. Why did we spend like all this attention on something to it?
Don't walk away.
I'm not walking away, I'm still here.
No, you're gone.
Two right to it. Yeah, I think so. Yes. Yes, but do you have an exact answer? This is an exact answer. Okay, simplify it. Sorry, side of 45. That's the correct decimal answer. Do you know sine of 45? Can you simplify the exact answer? No, we did that all the time. Your notes in the textbook and your screencast.
We didn't go over that. We expected us to know that.
That's your decimal answer. What's your exact answer? A lot of people give me 2.8 something for a decimal answer, but not an exact answer. What's going on? Don't you know the sine of 45 degrees? Right 2 over 2, right? What did we do all of September? Okay, ready? On the unit, be one with the unit circle. Christy, this is the notes you're talking about. Be one with the unit circle. You're 0, 0, right? Unit circle. This is 1 unit long. Where am I? Right here. What coordinates? Try again. 1, 0, right? This is 0, 1. This is -1, 0. This is 0, -1. Okay, so ready? The y values are sines. The x values are cosines. Remember? So what's the sine of 0? 0. What's the sine of 30? 1/2. What's the sine of 45? Right 3 over 2. What's the sine of 60? Right 3 over 2. What's the sine of 90? 1. Remember this? You forgot this already, right? Okay, so let's write it. It equals 1/2 a, which is 2, times c, which is 4, times the sine of 45 degrees. And people just did this. Cancel the 2's. You got 4 sine of 45. Yes, that's the exact answer, but that's not the exact answer in simplest form. You know that the sine of 45 is right 2 over 2, right? So it's 4 times right 2 over 2 is really what? 2 rad 2, right? I'll put it over here. 2 rad 2. Cows, moons, chickens, parsecs, angstroms, mongoose, inches, squared. Okay. Okay. That's the exact answer. What's your decimal equivalent? 2.828 square inches? Is that right? If you punch that into the calculator, I think so. Right, just for fun. Punch that up on the calculator. Why is this stuck? There it goes. All right, so what did we say? We said 1/2, 2 times 4 times the sine of 45. So you can just write it on the right here on the calculator. Quantity, 1/2 times 2 times 4 times the sine of 45. 2.828, there you go. All righty, or 2 rad 2. Same thing. So we rounded off 2.828. Questions? Comments? Problems? Dissertations? Yeah? You didn't get that? What happened? What happened? Come around. Nine over 2 would be 4.5. So 9 over 2 doesn't reduce to 9 halves. Just reduce it 9 halves, right? The 2 doesn't go either. If I don't make 2 and square root it into 2 different things, you square root it. You gotta show you what it is.
We square root it.
Oh, you've got half. Don't forget 1 half. A, B, sin, C. Because 1 half, A is the base and C sine B is the height. Yeah. Because, yeah, so
Question. Why is it square rooted?
why is what square rooted?
2.
Well, because that's what the sine of 45 is. It's rad 2 over 2. I didn't square root anything. The sine of 45 I plugged in rad 2 over 2.
Inches squared. Sorry.
It's still square inches. It's still an inch times an inch. The units represent the area, right? That you're multiplying inches times inches.
Okay, so
But the number is independent of the units.
Okay.
They're two
Just the
separate
unit,
things. Yeah.
inches squared.
Inches squared, yeah.
So if we have on a problem in the test, if we have more than 2 sides, then it's going to be inches squared or feet squared.
Usually, yeah, if you're doing area, yeah.
So then what if you have angles, like more than 2 angles? It's still going to be squared.
Well, it depends on what your sides are. If your sides, say, if this was 2 inches and 4 inches, you got square inches when you're done doing the area. If you have more than one angle, whatever it is, you're still going to have to get some sides. You're going to have to solve the triangle to get more sides. What if it was feet and feet, square feet? What if it was miles and miles, square miles? What if it's yards and yards, square yards? That's just units. Alrighty, yeah? Question? No? Yes? What?
There has to be room.
Well, it's 1 half times the 2 times the
Conversion too? Conversion?
Okay, it's 2 times 1 half, 2 times 4 times the sine of 45. 1 half times 2 times 4 times. All right, try that again. Here we go. All right, what? Yep. All right, how about number 7? All right, 7 says, they just draw the triangle for you, so here it is. Sort of like that. Something like that, okay? It says they labeled this angle A, angle B, angle C. In the book it says alpha, beta, gamma. That's what they mean. And you got 4, 6, and 9. Okay, so this is 4, this is 6, this is 9. All right, go. Do it. Find the area of that triangle. That way again. This is side type side.
So we need to know at least one angle to get the.
No, remember we did several examples where it was just side, side, side. So they gave you what? Little a. They gave you little b. They gave you little c.
I got 9.56.
That's it? That's the final answer, Regis? How'd you do it? Yeah, we'll check that in 1 sec. Remember to give an exact answer and a decimal answer, both.
This?
That's the second parameter. That's part of it. That's not the whole thing. Yeah. Heron's yeah. Heron. H-E-R-O-N. H-E-R-O-N. Heron.
No? I didn't know.
We're not solving for a sine. We're just giving the area. That's if you're solving for like a missing angle. Or we're not doing that. We're just finding the area. Yeah.
I know. That's a point five.
Decimals are allowed.
That's not 19.
6 plus 4 is 10 plus 9.
What was your semi-perimeter? Did you get it?
Oh.
9.5? Okay.
I didn't know that.
Yeah, you can do more than that.
I'm like, what are you talking about?
You don't have an angle.
I thought it was 5. I don't know.
What did Heron say? Boy, you guys are way behind the times. When did Heron do this? 5,000 years ago?
Oh, yeah,
Yeah, come on, catch up, catch up.
Right? I wonder if this thing right there exactly.
Well, that's an exact answer right there. 9.5, 9.5. Okay.
Oh.
This is a
Did you do that? Yeah. Okay. So your final answer was a decimal, I guess? What'd you get? 9.5 something, yes? Did you get 9.5 something? Yeah, because the semi-perimeter is itself a decimal, right? Let's see, what is it? A is 9, plus B is 6, plus C is 4, over 2 is 19 halves, or 9.5 if you like, right? Okay. So, you could write 9.5 times 9.5 minus 4, well, I'm starting here, times 9.5 minus 6, times 9.5 minus 9, and simplify that a little bit. So what are you going to write for 9.5 minus 4? 5.5, okay. Minus 6, 3.5 minus 9, 0.5. I guess that's an exact answer. You can get crazy and write this in terms of fractions, I guess. But that's okay for an exact answer right there. It's simple. It's simplified. You actually subtract it. It's good. Now, actually multiplying that out and simplifying that by hand, that's going to be a pain. So did you put it on the calculator? All right, so 9, 5, 3, and 0.5. Okay. Let's see what we get. The square root of 9.5 times 5.5 times 3.5 times 0.5, right? Did I mess up anyone? Is that it? And you got about 9.563, did you right? 9.563? Oh, it's 2, it's 2. 9.562, there you go. Square, no units. If they don't give you units in the question, there's no units in the answer, don't worry about it. Yeah.
Do you use the 1/2 A B side C when using an SAS sign?
Side angle, side right. You need an angle. We don't have an angle here, right? All right, well, wait a minute. Is there a way to write this exactly? More in simplest form? What is it, really? I think you could write it this way. This is really 9, whoops. This was 19 halves, right? Times 19 halves minus 4. But what's 4? It's 4 over 1, but I want it over 2 because I'm going to subtract fractions. I need common denominators. How do I write 4 over 1 as something over 2? 8 over 2. All right, so it's 19 halves minus 8 over 2. 19 halves minus what? 12 over 2. 19 halves minus what? 18 over 2. I think we might be able to simplify this radical a little bit better. Let's see. So it's 19 halves times what? What do you get here? Subtract. 19 minus 8 is 7? 11. And 19 minus 12 is? That's 7, okay. And 19 minus 18 is 1/2, okay. So let's see if we can clean this up a little bit better. What are you doing? Stop it. I'm here. Okay. Square root that. Now notice what you have here. On the bottom, 2 times 2 times 2 times 2 is what? 8, right? No, not 8. 16. And we're square rooting that, right? So it's really over what? It's really over 4. Dang it, why is it doing that? Stop doing that. Okay, but what's the numerator going to be? The numerator is a mess. Is that a perfect square? 19, 11 to 7? No, in fact, they're all prime. So you can't even factor out a perfect square and reduce that, right? Can you? So that's it. What is 19? What is 77 times 19? How about that? 4? 1463. 1463. That's the exact answer. You could write it this way. That's okay. But I think they're expecting this as an exact answer. Simplest radical form. I need two answers. I need an exact and a decimal. This is fine. This is probably what they expected, but this is fine. Okay? Because this is simplest radical form here. We took out all the perfect squares and we reduced all the square roots and everything, right? That's simplest radical form. All right, so that's it for today. Any questions? Any problems? Anybody stuck on anything? Yeah. Well, it's the exact answer and the decimal answer are both required. They're both required. Well, yeah, but this is exact. These are exact values. You didn't round anything off here, did you? This is exact. It's okay. It's simplified a little bit, not all the way, but I'll take that. Yeah. All right, so that's that for today. All right, YouTube, thanks for coming. Hope that was helpful.